Right, welcome world. I'm Irene Pease, your friendly neighborhood astronomer, and thanks for joining me for a quick stroll around our neighborhood. So this is kind of our celestial neighborhood. Tonight we're going to be looking at just our solar system, so staying very much in the neighborhood, a very small neighborhood. Um, but yeah, so this is actually the first in a series I'm pretty excited about. Been wanting to do for a while. I'm calling it Mission of the Month. So every month we'll be taking a look at a different mission, different solar system mission, because frankly, we haven't been out beyond the solar system yet. I'm going to leave the yet there. And this month, to kick it off, we're looking at BepiColombo. So it's a ESA JAXA mission, and we'll get to that in just a little bit. First, I want to give a shout out to some of the visuals that I'll be using. I'll mention these again as we get to them. In the background right now, you see OpenSpace, which you can download for free at openspaceproject.com. And also, in just a moment, we'll be switching over to Stellarium, which you can download and actually put that on all your devices. So you can find out more about that at stellarium.org. So to start off, I want to take a look at the night sky, just see what's happening up there, see if there's anything worth looking at. There's always something interesting. It's a big, crazy universe out there. So let's go ahead and just take a look at what's happening up in our sky these days. So starting off with some Stellarium. Again, this is kind of freeware you can use for your desktop. The app might be paid, but I think it's totally worth it. I have it on all my devices. And you can kind of use it to look around, plan what you're going to be viewing, plan what's going to be up in the sky on any night or even during the day if you like daytime astronomy, you want to know when the moon's out or something like that. So this is set for now in Brooklyn. So I'm in Brooklyn here. And there's this tree kind of over in the west that was blocking Arcturus over earlier, but I think that's set now. So kind of looking around the sky, I want to check out where the planets are. So Mercury, which is sort of one of the main guests of honor tonight with the mission we'll be talking about, Mercury already set just behind the sun. So it's setting earlier and earlier. It's actually going to be passing between us and the sun over the next week or so. But we have several other planets out in the night sky right now. So Jupiter and Saturn are down to the south, very bright. Jupiter is usually one of the brightest objects we see in the night sky, and Saturn not too far behind. So those are really great in telescope, binoculars, or even just with the unaided eye. So we'll be talking about more in the coming weeks and coming months. And of course, we have Mars. So Mars is actually brighter than Jupiter in our night sky for another week or so. Usually, it's not nearly as bright as Jupiter, but we just had opposition a couple days ago, and the close approach was a week before that. So those are not the same thing. Maybe sometime I'll talk about those in detail. But for tonight, just if you have a clear sky, go out, check out Mars. It's very bright. It's kind of hard to miss. It's the reddish orangish thing that's really bright in the east. And we have another planet, Uranus. So people are kind of focusing on Mars and how Mars is really bright right now, which is great because they should be, because it's pretty exciting. It's not always this bright every time it comes around. But Uranus is also a little bit brighter than usual these days over the next few weeks. It'll be going through opposition soon, so it's a little bit brighter in our sky, and so it's a good time to try and catch that with the naked eye. If you have a really, really dark sky, over the next few weeks, I'm going to be focusing on helping people find that. So we have a challenge for this week. I like to challenge people to try to find things in the night sky because you can see things just by looking up. How amazing is that? And so for this week, there's a couple really great constellations up here in kind of our autumn or fall sky. And you can see one of them is like this big square. Well, there's a little bit more to it than that, but I'm just going to call it the big square of Pegasus. And it's not just me, other people call it that too. So if you can imagine like a horse, yeah, that's a horse with wings, definitely. So the great square of Pegasus is 4 bright stars, or relatively bright stars. They're not super, super bright, but you should be able to make out kind of that square shape if you look pretty high in the east, a little after sunset. And then if you can find that, your next challenge is to look for this circlet of stars. This is the Circlet of Pisces. I'm not making these shapes up. This really is kind of, well, it's kind of more like a rectangle trapezoidy shape, but we're going to call it a square, and this is our circlet. So it's actually, I guess it's actually a pentagon, has 5 sides, but that's kind of part of one of the fishes of Pisces. Yeah, that's supposed to be 2 fish. So again, some imagination required. But if you can find the square of Pegasus and you look directly south of that southern part of the square, there's a circlet. So it takes a slightly darker sky than you might have if you live in a really bright city like Brooklyn. I could definitely see the square of Pegasus in Brooklyn, and if I go to one of the parks and squint really hard, I can see some of the circlet as well. So if I can, so can you. So that's a challenge for this week. Not so much of a challenge is to wait up till early in the morning or just get up early in the morning. If we watch kind of the night sky pass overhead, eventually there's Venus. So Venus is out and about in the morning these days. And even if you get up as late as, say, 6:30, 7 o'clock and go outside, Venus is really bright out there. So we'll be seeing a little bit of Venus in our tour tonight, as well as Mercury. Okay, so that's our challenge. And now my challenge is to try to change scenes. I think I want this button. All right, so if you recognize this machine, you get bonus points. What are bonus points worth? I don't know, not much. All right, so this is a NASA image. Even though this is not a NASA machine, it's a NASA image of our mission of the month, BepiColombo. At least this is most of it. This is what it'll look like more once it actually gets to Mercury. So it's on its way to Mercury now. It just flew by Venus around, well, midnight Brooklyn time. But yeah, early this morning in the rest of the world. And yeah, so that's why we're going to check out where it is going around Venus on its way to Mercury. So again, this is an ESA JAXA mission, so a joint mission, not including NASA, but still using like some of telemetry and whatnot. I don't know, I'm not a rocket scientist, but we'll take a closer look at some of these pieces in a little bit. I also wanted to show, before we get to OpenSpace and seeing some open space, I wanted to take a quick look at an animation. This is a really cool animation I found on, Wikipedia. I just restart this. So this mission launched a few years ago already. It launched back in 2018. And it turns out it's really hard to get from Earth, which is like this blue line, all the way into Mercury, which is the green line, safely. So you can see we've done, or the BepiColombo mission has done multiple passes. It did a pass of Earth where it came very close to Earth, and then it does 2 very close passes to Venus, and then multiple passes to Mercury before it actually catches up and has, we're going to call orbital insertion. Make sure I have this. Oops, there we go. Orbital insertion. So it takes like 7 years to go through all of that. So it's kind of a journey. It's not like you just like shoot something towards Mercury and have the sun's gravity pull it in, because then the sun's gravity will pull it in and it won't stop when it gets to Mercury. It'll just keep going. So actually being in orbit around Mercury is kind of a tricky thing. So math. It's all about math, kids. So we'll go ahead and pop on over to OpenSpace then. So this is again OpenSpace. You can find at openspaceproject.com, and I see they're also in the comments. So definitely check them out. It's open source software that you can use to explore the universe, which is what we'll be doing here. We're going to explore a very, very local corner of the universe. So what you see in the background, that's the Earth as it was a few days ago. They rewound time a little bit. The stars that you see in the background, that's all real data. So we have the Digital Universe Atlas that's partly curated the American Museum of Natural History in New York City. And we take data from all kinds of sources and pop it into here, and then we fly around here like Google Maps, but way, way better. It's like Google Maps for the universe if we want to go there. So I'm going to go ahead and move a little bit away from the Earth. And I think our first stop, again, was going to be Venus. So we saw kind of this very elaborate trajectory that BepiColombo is following to get to Mercury. If we move out, we can see kind of the inner orbits of the planets. So there's Earth with the orbit of the moon around it. And if we look back towards the sun, we can see where Venus is, way over there. So that's where Bepi's been. So we'll go ahead and pop over to Venus. So I was pretty excited about this Venus flyby. I know Venus has been in the news a bit lately. We don't need to talk about that. But it turns out there's already another probe in orbit around Venus. So most people are focused on Mars these days. Like there's 3 current missions going to Mars, so we'll get to those at some point. But there's a JAXA orbiter, a Japanese Venus climate orbiter, currently orbiting Venus and checking it out, mapping the clouds, cloud structure, all kinds of exciting things. And so I'm actually, let's see, a little bit closer here. So today we got a little bit closer to Venus. It only got to BepiColombo and its flyby only got to about 11,000, 10,000-ish kilometers from Venus, which sounds like a lot, but we're going to go into that same altitude. So if we zoom in here down, we're at 15, 14, 13, 12, 11-ish, just under 11,000 kilometers. So you can see, well, it looks a lot better here than it does, you know, from my local park in Brooklyn. I have to tell you, it's a lot more detail here. So go ahead and turn off the planet orbits and kind of spin around here. So really what we see of Venus from Earth is the phase, which is pretty neat. It's cool because Venus and Mercury both pass between the Earth and the Sun. They go through phases just like the moon does, but they're a lot smaller. They look a lot smaller because they're a lot further away than the moon. But we can see just, you know, maybe some kind of layering in the clouds. It's very, very bright. The probe actually had to turn off a couple of its systems so they wouldn't get blinded by the really, really bright Mercury. So it has a sun shield to protect it from the sun. But some of the instruments that are normally like checking out the stars, they had to kind of shut those down during the flyby so they wouldn't get blinded by the super, super bright spot of Venus. So that's kind of the altitude at which it did the flyby earlier today, or very late last night if you're on the west coast of the US. The next flyby that we can anticipate next year in August is going to be much closer. So if we take it down to about 550 kilometers. So that's just kind of about to crash into it. So we're still a little ways out. I think my field of view might be I need to reset my field of view, but it's getting really close in there. So it's gonna just kind of zing around there. Here we're actually seeing through one of the cloud layer maps. So we have a couple maps of Venus. Some, I guess, the Japanese satellite, the Onkotsuki, that's there right now. It's been there for the last 5 years or so, mapping the clouds of Venus and actually bouncing light off of the surface so you can get better surface maps. I'm going to see if I can just kind of turn off a different layer here. So we have all this wonderful data. And I want to kind of adjust some of these settings. Yeah, so we can get a slightly different map. So seeing more of the surface features, it's like turning off the clouds of Venus and saying, oh, that's what it looks like underneath. Um, so you can see some data artifacts in there from the maps. But yeah, Venus is, not super fun to land on. It's very hot. A lot of ancient volcanoes, a lot of lava flows, kind of toxic, not really pleasant to visit, but those clouds are pretty interesting. So, um, very interested to see what all we can learn about the atmosphere of Venus. There's still a lot that we don't know because we haven't really spent a lot of time there. So with the current JAXA mission around Venus and then future flyby next year of BepiColombo, we should be learning a bit more about Venus and what may or may not be in the clouds, what chemicals and processes could be there. So that's Venus. Nice, bright, hot, but not as well. It is hot. That is the hottest planet. I was gonna say not as hot as Mercury, but actually it is. It's hotter than Mercury, even though it's closer. Even though Mercury is closer to the sun. So let's pop over to the second hottest planet, where BepiColombo's ultimate target is. So we haven't had a whole lot of probes visit Mercury either. BepiColombo will be the third in human history. So the first was way back in the 70s. The Mariner missions were kind of out and about all over the inner solar system. So the Mariners sent missions to Mercury, to Venus, to Mars. So those were pretty successful. So I believe it was the Mariner 10 that did a few flybys of Mercury. It did a more direct route. So the Mariner got there in about a year. So it launched in 73, got there in 74, and did a couple of subsequent flybys because it was not in orbit. So it was still kind of going out around the sun. It was going too fast to slow down and stop and actually orbit Mercury. But the Messenger mission, several years later, so the Messenger mission, that was back 2004 launch, and it took 7 years to get into the orbit of Mercury. So it did kind of a similar loop-de-loop around the inner solar system that BepiColombo is doing. So it did the Earth flyby, 2 Venus flybys, and then 3 Mercury flybys before it was able to land itself in a stable orbit around Mercury. So the Messenger mission, again, that's just less than 10 years old that we got these other wonderful maps of Mercury, because the Mariner did, when it did the flyby, it didn't see all of Mercury. It only saw like about half of it because it kept flying by like the same side, because Mercury turns very, very slowly, like a lot slower than this. So Mariner got maps of kind of this part of Mercury-ish. But then with Messenger, we got some pretty detailed all over. So it filled in all the gaps, filled in all of this really cool spot up here. This is Calorus Basin, which is like a huge, well, you can tell it's a huge impact. So something really big hit Mercury a long time ago. Not sure how long ago. Someone else might know that. But a huge impact that actually sent shockwaves around the planet, and kind of sent up little highlands on the opposite side. So that was pretty traumatic for just a little planet. But even though we've had Messenger kind of like orbiting and mapping out some of the minerals on the surface, there's still a lot that we don't know. So I just want to maybe try to add another bit of a map here. I was having Facebook issues earlier, so I may or may not be able to get this other map to work. Let's try this one. Okay, I'm missing. There we go. So that's a little extreme. It's okay. So that's a little extreme, but you kind of get the idea. So this is a little false color, right? So basically very exaggerated, but just kind of mapping out some of the different features. So So Mercury, sorry, again, Messenger did get a lot of detail. So we know a little bit more about the field there. We know that it definitely has a magnetic field. We know a little bit more about the minerals on the surface, and we know that there seems to be some kind of ices in some of the permanent craters. So if I turn the kind of the sunlight on again, do this thing where we cheat and just kind of turn off the sun, right? So half of the planet is always in shadow, like any planet. But similar to the moon, up near the poles, there and even like just at extreme latitudes, you can have deep craters where parts of those craters are always in shadow, right? So so we're interested in learning more about the ices, like frozen, cold, hard water ice that could be in some of those craters, especially near the poles. So that's something exciting that BepiColombo will be checking out. I'm just seeing in the just seeing in the chat. There's a question if there's any special considerations for the spacecraft because of Mercury's proximity to the sun. Yeah, sun shield. That's the one thing that I can tell you. I'm not sure what else they have going on, but definitely a sun shield, so that it can, I guess, be halfway protected on its way there. And I don't think it doesn't have any extremely close passes to the sun. But yeah, it's definitely going to be hotter and brighter than it would be out at the orbit of Earth. So go ahead and turn off the sun and adjust our layering here. Unshade. So yeah, so what are we looking for? We're looking for, like, where did Mercury even come from? So we're not even sure, like, we know it, it formed with like the rest of the planets. It's much more dense than the rest of the planet. So, little fun fact: if you could turn off gravity and kind of let the planets fluff up a bit, Mercury would actually be quite a bit denser than the Earth. So there's what we call um, the uncompressed density. So some of the more massive planets are denser than they otherwise would be if you just like had a collection of materials, because gravity like squeezes them tighter together. Um, but because Mercury is so close to the sun, if you think about like a smoothie, like all the dense stuff sinks to the middle and all the foamy fluffy stuff is at the top. So Mercury, being closest to the sun, has like some of the denser material in our solar system. So, so pretty interesting, but we're still not sure why it even has the magnetic field that it does. So, hoping to learn a bit more about the core of Mercury, if it's like completely solid or liquid, or exactly how does it even have this magnetic field? If it's still geologically active, like what all is going on there? So, and again, I want to just point out a couple other fun things about Mercury. That one, I mentioned it turns very slowly. So it actually turns so slowly that a sunrise in Mercury can repeat itself, which there's a video about that if you want to. I can put that in the links in here. But because it's so close to the sun, it's going so much faster than the other planets. So I wanted to just take a quick look at the orbits of the planets before we pop back over to BepiColombo. Just want to see if we can turn on time a little bit, focus on the sun, and just another quick word about trying to get into orbit around an inner planet. We'll do a few days at a shot, several days, more days, right? So, yeah, so Kepler's laws of planetary motion and just, laws of gravity, laws of physics, we'll say, basically tell us that the closer a planet is to the sun, the faster it moves. So that goes for a planet when it's in its own orbit. So planets orbit the sun in ellipses with the sun at one focus. So sometimes the planet is a little closer to the sun, we call that perihelion. Sometimes it's further from the sun, we call that aphelion. So an individual planet like Mercury will go faster when it's at perihelion, slower when it's at aphelion. But also because Mercury is closer in, it travels faster than the other planets. Like if it slows down, then it'll end up crashing into the sun. So it has to go very, very fast to stay in orbit so close to the sun. So if you're trying to get from the Earth to an inner planet, you actually have to go faster. So Earth is traveling a lot slower than Mercury because it's further away. There's less of a gravitational pull, so it doesn't have to go as fast to maintain its orbit. So again, that's the really tricky thing, where we have this very complicated orbit for these probes, the Messenger and now BepiColombo, trying to get in and into a stable orbit around Mercury. So you have to get away from Earth, and then you have to get closer to Mercury. So you have to speed up, but not too much, but just right. So it is quite of a process, and it does take quite a while to get over there. But it's due. Again, we have the one more Venus pass, a few more Mercury passes, and then by December 2025, so about 5 more years and change, it'll be safely in orbit around Mercury. And then it gets really exciting. So check back. But before you do, I just wanted to say just a few more words about this. I wanted to pop back over to BepiColombo. So once it gets there, it actually loses its jetpack. So it has this Mercury transfer module. It's like a little Airbus. So that would have been like on the back end, where it has like its ion thrusters. Yes, that's a thing. It has ion thrusters. So once it gets there, then it detaches and it actually becomes separate pieces. So the Mercury magnetosphere orbiter is going to be spin ejected. So this little bit pops out and maps the magnetosphere, we hope. And then this is our sun shield. So this bit in here has just kind of been protecting some of the other bits. So that will get popped out. And I'm not sure if that's supposed to crash into Mercury or what. And then the rest of the probe, that's the rest of the Mercury Planetary Orbiter. So it's actually like a 2-for-1, pretty amazing bit of engineering between a couple of really amazing space programs, JAXA and ESA. So if you want to learn more about BepiColombo, go ahead and check those out. If you want to see more tours of the solar system and kind of what's up in your night sky, then you can join me again. So thanks so much for joining me for this first mission of the month. We'll have another one sometime next month. In the meantime, just go out, enjoy the skies. Again, I'm Irene Pease, your friendly neighborhood astronomer, and you've been viewing Stellarium, which you can find at stellarium.org, and OpenSpace, which you can find at openspaceproject.com. You can find more friendly neighborhood astronomer stuff at friendlyneighborhoodastronomer.com. Thanks for watching, and have a good night.